So last time we talked about arithmetic series, which was the sum of the terms of an arithmetic sequence. Today we're going to talk about geometric series, which is just the sum of the terms in a geometric sequence. We have a new formula for geometric sequence, and that formula looks like S sub n, where n is the number of terms, times a sub 1 times the quantity 1 minus the common ratio raised to the n power divided by 1 minus r. So that's kind of a complex formula to kind of commit to memory, so we'll always have our notes with us to refer back to. Well, let's take a look at this first example where we're adding the terms 3 plus 6 plus 12 plus 24 plus a whole bunch more terms, and then the last term being 3072. So I want to add these together. Well, the problem is I don't know what's going on in here, and even more specifically, I wonder what term this is. This is a sub n. I don't know, like what term is this? Well, we can figure that out. I know for sure that a sub 1 is 3. I see that the common ratio is 2, because to get from one term to the next, I would multiply by 2. Multiplying by 2. And so then if this is 3072 equaling the first term, which was 3, times the common ratio to the n minus 1. Well, let's just do some math. So I'm going to get my calculator out, and the first thing I'll do is divide both sides by 3. So 3072 divided by 2, no, by 3. I meant by 3. 3072 divided by 3 is 1024 equals 2 to the n minus 1. I don't know. Well, what does an exponent? A logarithm. So I'm going to log both sides to undo an exponent. Now the exponent drops down in front. And log base 2 is just a number, so I can divide both sides by log 2. Divide both sides by log 2. Okay, I have something is equal to n minus 1. I don't have my calculator pulled up, so I'm just going to type in my own personal calculator, 1024 divided by, no, log of 1024 divided by log 2, and that gives me 10. And then if I add 1, okay, n is equal to 11. N is equal to 11. So there must be, let's see, 1, 2, 3, 4, 5. There must be 6 terms between 4 and 3072. Well, anyway, now that I know what n is, thank you, formula, for helping me out with that. Thank you, geometric sequence formula. I can find the sum of those 11 terms. So the sum of the 11 terms will be equal to 3 times the quantity 1 minus 2 to the 11th over 1 minus 2. So 1 minus 2 to the 11th, this much is negative 2047. I'm multiplying that by 3, and then I'm dividing it by negative 1. And that gives me 6,141 for a final answer. I don't know what happened there. Let's erase that. All right, 6,141 is the sum of all of the terms from 3 to 3072 in that geometric sequence. Take a look at letter B. So in letter B, I clearly have 1, 2, 3, 4, 5, 6 terms. So n is equal to 6. My first term is negative 15. And what's the common ratio? What do you think the common ratio is? Did you say negative 2? 30 divided by negative 15 is negative 2. Negative 60 divided by 30 is negative 2. 120 divided by negative 60 is negative 2. So yep, common ratio is negative 2. All right, so I want to find the sum of the first 6 terms. I use the formula from above. I'm going to shrink this down so I can see it all on one screen. A sub 1 was negative 15. 1 minus negative 2 to the 6th power, all over 1 minus negative 2. So do you see how I used kind of a lot of parentheses here? Parentheses are free. Use lots. So I used parentheses because I was dealing with a lot of negative numbers. Now I'm going to very carefully type this in my calculator. -2 to the 6th power. In fact, you know what? I'm going to pull my calculator up. Pause. Yeah, this one's worth pulling out the big guns for. All right, so here's my graphing calculator. Let's see, I need -15. So I'm going to go -15 times the quantity, 1 minus, in parentheses, I'm typing -2 and then raising that to the 6th. Notice how I've done that. Close the parentheses. And then I need to divide by 1 minus -2. I didn't get my division bar in there, and I need to put all of that in a set of parentheses. 1 minus the quantity, -2, close that bottom quantity. Okay, so I'm going to pull this over here. Did I get that correct? -15 times the quantity 1 minus -2 to the 6th, close quantity, divided by 1 minus -2. All right, drum roll please, hit enter. I came up with 315. Okay, I'm pretty sure that's right. I could check it, of course, just by hand. Let's see. I'm not going to, you trust me, I'm sure. Okay, and then last example here before we call it a day. Let's find the sum. I'm going to give you a new geometric series. And, oh, actually I'm not. I'm going to give you summation notation. We're going to go from n equals 0 to 20. And we have 4 times 1/2 to the nth power. All right, so it looks like I've got 20 terms. The 0th term, that doesn't mean anything. Well, actually, the 0th term, though, would technically be 4. So if I didn't multiply by 1/2, I'd start with 4. And then all the way up to the 20th term. So I've got 20 terms. My first term, a sub 1, is 4. My common ratio is 1/2. So this is a calculator punch like you know by now, I'm sure. Or we could just say s sub 20, using the formula, is equal to first term, which is 4, times 1 minus the common ratio of 1/2 to the 20th power, all over 1 minus the common ratio of 1/2. Okay, I've got my calculator out, so I'm going to do both things. I'm going to evaluate sigma, and I'm going to evaluate the formula, and hopefully I get the same answer. Oh boy. Okay, what do you want to do first? Let's do the formula first. There's just a lot of typing there. So I've got 4 times the quantity, 1 minus 0.5 to the 20th. Get back down on my level. Divide by the quantity, 1 minus 0.5. Okay, did I type that in right? Looks good. And I get approximately, oh boy, that's pretty close to 8. So I'm going to say, rounded 8. Now, let's do sigma. So remember, you're going to find sigma in the math menu. You're going to go all the way down to 0, summation notation right there. We're going to go from x equals 0 up to 20. And then what we're working with is 4 times 0.5 to the x power. I used n. I'm going to use x's because that's the first variable that comes up when I type in my calculator. And as you can see, I came up with exactly the same answer. So I'm going to call this one 8 as well. So you have options. You can either use the summation on your calculator or you can use the formula. All right, that's all I have to say about geometric series. We'll practice using the formula tomorrow and identifying all of the important pieces that go into the formula. See you tomorrow.